ladies. So the last couple weeks, we've covered how to simplify radicals, and we've also covered how to use the quadratic formula. So this week, we're going to learn how to kind of apply everything we've learned into real-life situations. So before we get started, I just want to kind of go over two important formulas that I really want you guys to keep in the back of your mind. So first, we have our quadratic formula, which is x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And another one I want you kind of to think back on is our vertex formula. So we learned this back when we were graphing quadratics. It is that formula that gives us that high point or that low point, and remember we called that the vertex. And this little formula is x is equal to the opposite of b over 2a. And you guys might notice they actually share some similarities. So for example, we have the opposite of b over 2a, and look, we have that right over here as well. This second portion over here helps us find something that we call the discriminant, and that's something that you guys are going to get to cover next year if you have me again. So let's get started. So let's look at part one. So part one is how to write out an equation and find and find the height of an object at a specific time. So I have a person is standing on a diving board that is 20 feet above a pool. She jumps off the diving board with an initial velocity of 15 feet per second. So this sounds more difficult than it really is, to be honest with you. So let's just break this down. So we have a diving board that is 20 feet above the pool, and we are jumping off this board with an initial velocity of 15 feet per second. So let's go ahead, let's start this. So part A gives us a formula. So it says given h of t is equal to negative 16t squared plus vt plus s, where h is her height in feet above the water at t seconds, and v is her upward velocity. S is her starting point. Create an equation that can be used to model her jump into the pool. Okay, so we actually know a lot of this stuff already. So we want to create an equation, right? So they gave us a base to start with, right? They gave us h of t is equal to negative 16t squared plus vt plus s. Well, they also gave us v and they gave us s. They said that s was your starting point, right? And they also told us that we are starting 20 feet above the pool. So I'm just going to change that s to be a 20. And v is our velocity, right? So they gave us a velocity of 15 feet per second. So I'm going to go ahead and change that v to be 15. And again, we still have this negative 16t squared. So that 16t squared is actually going to be Earth's gravity. So this is that constant that we're always going to use, that coefficient in front of t squared. And this has to do whenever we're talking about feet. So it changes based on, whatever measurement you're talking about. So it would be different if we had meters, it would be different if we had miles, etc., etc. And we are actually done here. This is our formula. We have our negative 16t squared. We plugged in our initial velocity and we plugged in our starting point. So part B asks, what is her height after 1.5 seconds? Well, what does seconds represent? Seconds is your t, right? T is time. So I have a formula. I have the formula that we found from part A. So I have h of t is equal to negative 16t squared plus 15t plus 20. Well, I already know that t is equal to 1.5. So everywhere I see a t, I'm going to go ahead and plug in 1.5. So I have h of 1.5, because I'm plugging in 1.5 for t, is equal to negative 16 1.5 squared plus 15 times 1.5 plus 20. Next thing I'm going to do is I'm just going to throw this into my calculator or into Desmos, and I am left with 6.5, and this will be feet. So something that I do want you guys to get in the habit of, especially with word problems, is actually writing out a sentence. So for example, this one would be at 1.5 seconds, she is 6.5 feet from the pool surface. Okay, so let's go ahead. Let's look at part 2, and I'm just going to box this out. So part 2, the storm chaser at Kentucky Kingdom has a velocity of 76 feet per second. The coaster can be modeled by the following equation. H of t is equal to negative 16t squared plus 76t plus 50. What is the maximum height of this roller coaster? So again, in part 2, we're going to be looking at how to find the maximum height of an object. And you're going to see typically a quadratic formula. We're going to use our vertex formula since that gives us our highest point. And I think you guys will be great with this. So again, let's just break this down a little bit. We talked about how our vertex point gives us that high or that low point. Because of that, I'm going to be writing out my formula. So I have h of t is equal to negative 16t squared plus 76t plus 50. This is already in standard form. And what I mean by standard form is just like what we did last week with the quadratic formula. We know that a is negative 16, b is 76, and c is 50. And since I need to know what the vertex is, I can go ahead and use my vertex formula. And what I'm going to do is I'm just going to plug in my values for b and for a. So I know that x is equal to the opposite of b, so I have negative 76 all over 2 times a, which is negative 16. And I'm just going to go ahead and simplify this. So I have negative 76 divided by negative 32, and this is going to give me 2.375 seconds. So at 2.375 seconds, we will reach our max height. But something to keep in mind is, did they ask us for the time? No, they asked me when the time is for the first part, but they want to know what is the maximum height. We only know when right now. We want to know what the height will actually be. So just like in this part B for number 1, if I know the exact time that I want to be looking at, I can just go ahead and plug it in to my original equation. So I'm going to take this value that I just found. That's pretty light, so let me make this a little bit darker. So I'm going to take this value that I already found, and I'm going to go ahead and I'm going to plug it in to my equation. So I have a specific time. I'm plugging it in for t because we know that t is time and we have seconds. So my h of 2.375 is equal to negative 16 2.375 squared plus 76 times 2.375 plus 50. I'm going to throw all of this in Desmos, and I got 2.375. So this ends up being 140.25 feet. And again, we want to go ahead and write this into a sentence. So I have the max height of our roller coaster is 140.25 feet. So again, let's recap. So first thing we did was we wanted to know the maximum height, right? We know that our max is our vertex. So what we did was we went ahead, we used this little formula with the equation that we were given. We found the specific time that we would reach this top height. And since we knew that specific time, we went ahead and plugged it into our original formula to get that specific height of the roller coaster. Okay, so let's look at part B. Adrian is playing with a rocket whose height can be modeled by the equation h of t is equal to negative 16t squared plus 112t plus 10. What is the height of the rocket in feet? So we want to do the same thing as part A, right? We want to use our formula, use the vertex formula. We want to find that highest point, right? So we'll find that time, we'll take that time, we'll plug it back into the formula to figure out exactly where the rocket is height-wise. So let's get started. So I have my h of t is equal to negative 16t squared plus 112t plus 10. We know that A is negative 16, B is 112, and C is 10. Let's go ahead, let's plug that into our vertex formula. So we know that x is equal to the opposite of B all over 2a. So this really just gives me negative 112 over negative 32. And this simplifies to be 3.5. And we're talking about time, so this will be seconds. So we found that specific time that the rocket will hit its max height. So I'm going to take this time and I'm going to plug it back into our original equation just so that we can figure out height-wise where it is. So let's do that. So I got h of 3.5 is equal to negative 16. I'm plugging in 3.5 for t. Plus 10. And I'm just going to plug all of this right in my calculator. So I got h of 3.5 is equal to, and this ends up being 206 feet. Okay. So before, if I wanted to write out my cute little sentences, I have at 3.5 seconds. Our rocket reaches its max height of 206 feet. So I just went and combined both of those sentences because really you don't really need to write me a whole paragraph. I just need to know that you understand what these numbers mean and how we actually utilize them in real life. So again, my 3.5 seconds came from using that vertex formula. I found the specific time that the rocket will be at its vertex. I wanted to know the height, right? So I went and I plugged that 3.5 in back into the original formula, and I got the height, the actual height in feet, which was 206 feet. But we are not done because this question asked me something else. So it says, what is the height at 2 seconds? So just like part 1 and part B, if I want to know the exact height at the rocket at a certain time, I'm just going to plug in that time, right? Just like we did with that 3.5 seconds. So I'm going to plug in this 2 right in. So I got h of 2 is equal to negative 16 2 squared plus 112 times 2 plus 10. And this, once I plug it in, once I plug this all in, I get 120 feet. So at 2 seconds, our rocket is at 120 feet. Okay, let's look at part 3. So part 3 is just, how to calculate when the projectile will actually reach the ground. So something I just kind of want to draw out for you is we are dealing with quadratics, right? So let me just see what this question is about, and then I'll draw you a nice picture. So we have a soccer player kicks the ball with an initial velocity of 7 feet per second. 70, sorry. And a starting height of 0 feet. So it's going to start on the ground. Nice. Write the equation of the ball and find the time when the ball will hit the ground. So we got our little person, right? We have our ball. We have our nice grass. And he is going to kick this ball, right? It's going to hit some max height at some time, and it's going to hit the ground again. So these are actually things that we've talked about in class. So for example, if you were to think of the grass or the ground as the x-axis, this would be a 0, and this would be a 0 of the quadratic, right? Those would be 2 of the solutions. And we've done hundreds of, practice problems actually helping us get zeros. We've factored, we've graphed, we've done the quadratic formula. When we have these real life examples, you will probably rely more on the quadratic formula than on graphing, just because these problems, the numbers tend to be a little, ugly. We can't really factor them that often. So let's get started. So I have my formula that I need to make, right? So we know typically we start off with an h of t. we have is equal to, and if you look at all these past problems, we've always had the negative 16 t squared in the front. And as I said kind of in the beginning of the video, that is going to be due to gravity, right? So we have gravity on the Earth, and since we're dealing with feet, we have negative 16 t squared. Then we know that our velocity goes in the middle, right? So what is our velocity? We have 70 feet per second. So we have 70 t. And our starting height is 0 feet. All right. So we know we want to do the quadratic formula here, right? Because we want those two zeros. So I have A, which is negative 16, B, which is 70, and C, which is 0. Actually, it's nice that we have a 0 because this will go a lot faster. So what was the quadratic formula again? Let's go through that. So we have x is equal to the opposite of b plus or minus b squared minus 4ac all over 2a. So I'm just going to plug in my a, b, and c. So I have x is equal to the opposite of b plus or minus b squared minus 4ac all over 2a. Alright, so something nice that happens here is since I have a 0 times this little chunk, I'm just going to scratch it out because we know anything times 0 is just 0. So let me just simplify this a little bit. So I got negative 70 plus or minus, and look how nice this actually is right here. We have 70 squared. Well, we know that the square root knocks out a square, right? So this is actually just going to be nice and neat. It's just going to be 70. And we have 2 times negative 16, which is negative 32. And again, if you did not really see this, just take the square root of 70 squared, and you will see that you're stuck with 70 again. 70 squared gives me a perfect square of 4,900. Or 4,900, however you want to read it. And that's perfect. And that will break up into 70 and 70. So that's where that's coming from. So we know when we get to this point, and if you struggle with this part, just reference back to the video on the quadratic formula. We split up into two different equations, right? So I have x is equal to negative 70 plus 70 over negative 32. And I have x is equal to negative 70 minus 70 over negative 32. Okay, let's simplify this. So my first one, negative 70 plus 70 goes away. That's going to be 0 over 32, which is just 0. And negative 70 minus 70 is negative 140 over negative 32. And this actually simplifies. So I have x is equal to 4.375. And I like to just either round that third decimal place, or you'll learn about truncating later. So if I get you next year, I'll teach you guys about it. But for now, just 3 decimal places. You guys know how to round already, so you guys should be fine. But now let's talk about the context of these answers. So which one is actually going to be the answer to this problem? Because we want to find when the ball is actually hitting the ground, right? Well, it starts at 0, right? It starts on the ground. We can't really use this answer here, right? Because this is telling me that we already kicked the ball and, no time has passed. So in the context of reality, we have to use this answer right here. That's the only answer that makes sense. What this answer tells me is that after 4.375 seconds, the ball hits the ground, and that makes sense. It would not make sense if no time passed with 0, right? So our soccer ball will hit the ground after 4.375 seconds. Okay. Okay, so let's do part B. So similar situation here, right? We have our little baseball player. Let's see, he's got a bat. Maybe I'll give him some ground, whatever. He smashes the baseball with an initial velocity of 20 feet. Oh, wow, this is 120 feet per second. That's far. All right, so he's going to hit this ball, right? And it's going to land at some point, probably a lot nicer than what I drew. So let's get started. So we got to make our equation first, right? So I have h of t is equal to, we know we're going to have negative 16t squared. I need to know the velocity, right? So they tell me an initial velocity of 120 and a starting height of 5 feet, which makes sense, right? Because he's standing up, the ball is going to be in the air. That's great. So I have my initial velocity of 120 feet, and we have a standard position starting point at 5 feet. All right, so we have our equation. Let's have our A, B, and C. So we know that A is negative 16, B is 120, and C is 5. So we're going to use the quadratic equation just like before, right? So I have x is equal to the opposite of b plus or minus b squared minus 4ac. All right, and it's all over 2a. Okay, so let's simplify this. So I got x is equal to negative 120. So I got plus or minus 14,720. And this is going to be all over negative 32. All right, so when we used the quadratic formula last week, we learned about simplifying what's underneath our radical, right? And we did that the week before as well. So what I'm going to do is I'm just going to try to simplify it using the perfect squares that I know. And this actually breaks up into the square root of 64 times the square root of 230. So let's go ahead, let's rewrite that. So I have x is equal to negative 120 plus or minus. We know that the square root of 64 is 8, and I can't do anything with 230, unfortunately. And this is all over negative 32. Okay, so let's look at this answer. I can, of course, rewrite this, right? I have my two situations. So I have x is equal to negative 120 plus 8 square root 230 all over negative 32. And I have x is equal to negative 120 minus 8 square root 230 over negative 32. Okay, so we have some trouble here, right? Because my first problem, I could simplify it really easily because I didn't have a radical involved. But now I have a radical. And in the concept of time, does this even make sense? Like, what the heck? What does negative 120 plus 8 square root 230 even mean? I don't even know, right? So what you have to do is we want to get in the habit of turning these into decimals for these situations where we have real life, right? Because mathematically, this is very precise. We know exactly the time, but unfortunately, we don't report time like this in the real world. So, regular math problems, this would be great, but if you were to report a time, somebody would look at you funny if you were like negative 120 plus 8 square root 230 over negative 32, right? So I'm going to show you guys how to simplify this in a way that you could actually talk about it. So my tip for you all is to go ahead and write the numerator in parentheses and then divide it by the denominator. So I typed into my calculator, and you can actually do this in Desmos as well. And I think phones do the square root fine as well. You just have to turn your phone horizontally. So I typed the numerator, and then I divided it by the denominator, and I got x was equal to negative 0.041. I did the same thing for my second situation, right? I put my numerator in parentheses, I divided it by my denominator, and I got x was equal to 7.541. Again, I just rounded at the third decimal place. That's right over here. If you have trouble with rounding, just text me, let me know, and I will help you. So again, we have to think about the context of the problem and which answer is going to make sense, right? Does it make sense that we have negative time No, like this is not Back to the Future. This is not what we're messing with. But this answer right over here does make sense. It does make sense that will smash a baseball and it'll hit the ground 7.541 seconds later. Okay? So I'm going to just write that into a nice little sentence so that we can sound articulate. So we have our baseball will hit the ground after 7.541 seconds. All right, that covers every type of example for this week. Please feel free to reach out if you guys are struggling with any of this, and good luck.